Hey guys, it's Mr. Hing here. Welcome back to the trigonometry graph series. Wow, what a journey it's been. Please have a look at the playlist of trigonometry graph videos. I hope it's been a blessing and helpful. What we're going to be looking at today is purely we are looking at amplitude. Okay, so what is amplitude? How do we calculate it? Things like that. So the first thing that I wanted to start with is a few notes that we need to remember. Okay, they are vital and so important. Right, when we talk about amplitude, we look at how a graph, well, I'm speaking specifically to the sine and cos graph. So we talk about when the graphs have been stretched. So look at my laser over here. I can zoom in a bit more. Oh, I zoomed in a lot there. Sorry about that. Right, let me just go over here. So what I mean by that is, if you look at my laser, the original graph, a sine graph, will look like this in black. So it will come here and then go like that, okay? Something along those lines. Now, when I go ahead and I stretch my graph, you'll see that in yellow, I'll show you that this part over here now becomes stretched and it comes further up. So I'll just take that away. So it has now become the green graph, and this point over here has now stretched and gone lower down. I hope you can see that. But look on this side over here. Over here, this is when I just simply shift the graph vertically. So can you see that if I use all my pointers, so for instance, the original sine graph has point somewhere along the line like this. This is more or less the shape, and you'll see that it has gone up there, it's gone up here, it's gone up here, it's gone up here, and it's gone up there. So every respective point on the original graph has moved up. So every point has shifted up a specific unit or specific amount. It's gone up or down, in this case up, and that is not what I mean when I talk about amplitude. I'm talking about the stretching of a graph. Okay, so that is what I'm talking about regarding amplitude. Okay, so now that we know what it kind of looks like, I want to explain really important tips when it comes to sine and cos graphs, things that we need to remember. Okay, so one thing that we can use, it's such a nice thing to know, is that when I have a number in front of a sine or cos graph, remember, it means there's an imaginary multiplication sign over there. Okay, so what that means is this A, whatever number this is going to be, this becomes your amplitude. Okay, please remember that if you have a number in front of or multiplying into the sine or the cos, that number over here can and is your amplitude. Not for tan, please, not for tan, but for sine and cos. Let's have a look at two examples over here. So if I have maybe 3 cos of x in that is my graph. Maybe it's saying y is equal to 3 cos of x. My 3 is going to be my amplitude. And the same thing over here, if I have y equals 4 sine x, 4 is going to be my amplitude. So I wanted to really teach you that this is such an important trick or skill or note to know, that the number being multiplied into the cos or sine graph is your amplitude as well. Now, please bring your attention over here. There is something to note regarding our tan graphs. Please. Okay, just take just take some time to pause and listen to what I'm about to say here. So, in a tan graph, it can still have a number in front, but it is not the amplitude when it comes to a tan graph. So, Mr. Hing, what the heck do you mean? Listen over here. If I say y equals 4 times tan x. So can you see the resemblance between this and this? We have a number in front of our tan or cos or whatever. But when it comes to a tan graph, please, this 4 over here does not represent the amplitude. Okay, I hope you understand. So with regards to sine and cos, the number in front is your amplitude. But when it comes to a tan graph, the number in front is not the amplitude. Okay. Right, let's move on to this point over here. This is the second last point I want to highlight to us, and that is when we have a graph, a sine or cos graph. Okay, have a look at this A. This A, I've just said it so many times in the video, it affects or it represents the amplitude in the sine and cos graphs. Okay, so that is important. Now when it comes to our Q, this affects the vertical shift if it goes up or down. Okay, so please remember that. Very, very important. And then lastly, the last point that I want to show us is how when we get a given graph, which is a question that we're going to be looking at now. Say now, for instance, we get given this graph over here, we get given this graph over here, and it asks us to determine the amplitude, or A, for the sine and cos graph. Now, there are two ways of doing it. The first way here, this is a textbook way, and then here I've also heard that you can do it this way, and it does actually work. So I'm going to give it to us in two different instances. So let's have a look at this first graph over here. So I just want to keep the two. Let me just put number 1. This is like our first method, and this is our second method. So over here, this is going to be a y is equal to a, and then it's a sine x graph. So now the question would be, it can either be, I won't write it down, but the question could say maybe determine the value of a, and I've taught you that a is the amplitude. It could maybe ask determine what is the amplitude. It can maybe ask determine the equation of this graph, because if you get the answer of a is equal to whatever, maybe it's not this answer, but say now it's a equals 5, then obviously you can determine the equation y equals 5 sine x, and that is your answer if they had to say determine the equation. So let's actually go and answer what they are saying. So this graph over here is represented by y equals a, we don't know what that is, and sine x. So let's say, for example, they say determine the value of a. So we know that in a sine and cos graph, a is the amplitude. So let's go and do that together. All right, so let's go ahead and use our first method. Okay, so our first method is going to be, well, let me first tell you and remind you that you need to remember and you need to know what the standard form or standard like a normal sine x graph that has not been affected, what shape that must have. So it goes like this, remember, and there's a 1 as its height, and the lowest point is -1 over there. So now that we have that in mind, we must just use that knowledge at certain points. So let's go ahead and use method number 1. So we're going to say, okay, the maximum y value minus the minimum y value. I'm just going to shift down a little bit, guys. So, and then we need to divide it by 2. Right, so let's go ahead and get our maximum value. So our maximum value is 2. So we're going to say 2 minus, and then our minimum value is going to be -2. I hope you can see that over there. So it's going to be -2 all over 2. So 2, this becomes a plus. So 2 plus 2 is 4. So it'll be 4 over 2. And that is going to give me an amplitude, or A is going to be, therefore, 2. Okay, so that is method number 1. Method number 2, I'll zoom out a little bit so that we can keep it over here. So just look at my laser. This is method number 2, where we know in our mind what the original or standard form looking sine graph is, and then we're going to say, okay, if our new graph has certain points, what happens? Okay, so let's write that in over here. So original, right, so we have original, new, the high point for both, and then the low point for both. So do you remember in our original graph, we have to know this, that our highest point is +1 and our lowest point is -1. So now if I had to look at my graph in yellow over there, we can see that my highest point is going to be, my highest point is going to be 2 and my lowest point is -2, which we've already identified. So now my highest point is going to be 2, my lowest point is -2. So now guys, when it comes to amplitude, have a look over here what I said. We need to ask ourselves what it needs to be multiplied by something in order to make this work together. So you literally go and you ask yourself, what am I doing to get from 1 to 2? Well, I'm multiplying by 2. And over here, what am I doing to get from -1 to -2? Well, again, I'm multiplying by 2. And that is another way to show what your amplitude is going to be. So we can say that the original graph has been multiplied by 2, and that is actually what happens. Because if our A, okay, we know that our A is 2 now, right? So if we take this A away and we say that it is now 2, is that not what's happening? It's 2 being multiplied, an imaginary multiplication sign to that graph, and that is going to be our final answer, depending on what the question was. Maybe it asked you determine the equation, you would put this answer. If it was just saying determine A, you can say A is 2. If it's asking for the amplitude will be 2, etc. Okay, I hope this is making sense, guys. And then over here, guys, I didn't write it in. So this graph, let's say it's asking determine, I just want to use red again, determine the equation, and they give this to us. So we know that it is going to be a type of cos graph, and it has been, the amplitude is being affected. So let's go ahead and work that out. So the first method, I want to do both with you. So it'll be y, the maximum value minus the minimum value all over 2. So let's go and have a look. So our maximum value is 2. Our minimum value is -2. Sorry, it's minus. Please don't do that in your test. So it's minus and then -2 all over 2. That becomes 4. 4 divided by 2 is 2. So we get the answer of 2. The other method that I showed you is when we go and we say the original and then the new one, the high point of we need to determine, and the low point. So the original, do we remember, guys? We need to know that. So remember, in the original unaffected, just a normal cos graph, it goes like this. Oh, that was a bad point. But anyway, it's more or less like this. And our top point is 1. Our lowest point is -1. So it's 1 and -1. And then in our new graph over here, the highest point is 2 and the lowest point is -2. So again, we ask ourselves what is for amplitude. Remember, for amplitude, we ask ourselves, what do we do regarding multiplying? We are multiplying by 2. Okay, and then we are going to say therefore it is 2, the amplitude, or A. So then if it asks for the equation, you will just put y equals 2, not sine, cos of x. Okay, let's quickly go and determine the, just for fun, the domain. Let's go and determine range, domain, period, and amplitude. Remember, these 4 terms are so vital. They will come in your test time and time again. So let's go and answer those together. So what is the range of this graph in yellow? Well, our maximum point, well, I like to start from the lowest. So the lowest point is -2, and then it goes all the way up, and the top point is 2. So you'll say y is the element of or belongs to from and including -2 all the way to +2. Domain, it's going from the 360 all the way through to +360. So we'll say x is the element of or belongs to from and including minus 360 all the way to positive 360. Period is always 360 degrees for sine and cos in grade 10. And then amplitude we've already determined it is going to be 2. Right, let's do the same for the sine graph over here. So what is my range? Again, it is going to be from minus 2 to positive 2. So y is the element of or belongs to from minus 2 and including it to 2. Domain, it's actually so similar to the other graph. It's going to be from minus 360 all the way to 360. Period, I've said it is 360, how long it takes for the graph to repeat itself. Amplitude, again, we worked out as 2. So you'll actually see that it's the same answers. Yeah, but with all of that being said, guys, what we are going to be moving on to now is we are going to be having a look at how do we draw difficult graphs, and then I'll hopefully get to exam questions. And then the other one was, and I might just have a look at how to determine more difficult equations for graphs. Okay, guys, see you in the next one.